Hi everyone, and welcome to today's Rancher Online Meetup. We're going to be talking about Project Longhorn today, and looks like we've got a fantastic turnout. I'd like to start by introducing myself. I'm Shannon Williams, one of the founders here at Rancher, and I'm joined, as always, on our meetups by Darren Shepherd, my co-founder and our chief architect. And today I have another of our co-founders, Sheng Liang, our CEO, who's going to be on the call, as well as Sheng Liang, who is our storage architect here at Rancher. So we've got a great agenda with lots to cover, and I'll move pretty quickly through. First things first, as always, just to remind everyone, this is really a meetup, not a webinar. And because of that, it's meant to be very engaging. We love your questions. If you haven't already attended a Rancher meetup, you'll certainly learn today. These meetups have all sorts of discussions on all sorts of topics. We try to have an agenda, which we'll dive into and we'll talk about, but we end up often covering lots of different topics as they come in from people interested in areas around Docker and containers and microservices and cloud computing and Rancher and such. So as a meetup, what that means is we don't really set a time to be done. We go as long as there are questions. And your questions are welcome, so just keep asking them. We have this questions function in GoToWebinar that you can put your questions in. If you put a question in, I'll almost always try to respond to everyone, so everyone can see the questions that are being asked. Sometimes your question will get asked out loud. Sometimes we'll open up your line if you'd like to ask your questions in person, especially if it's a more complex question. So feel free to fire away questions, and we'll answer them all as they come in. As a meetup, we demo. This is not a bunch of slides, though today we do have quite a few slides because we're going to be talking in quite a bit of depth about what Longhorn does, but we'll be demoing it as we go and showing you how to set it up, how it works. But we always demo in these meetups, and we do them live, so things break. Sometimes they break and we can fix them quickly, and other times they break because networks don't work or our demo gods are not in our favor. And so, we tend to see that the best thing to tell you is just be patient, and as we go through, you'll find we'll do our best to explain what's happening. As a meetup, we really love to get to know everyone who attends. We have thousands of people as part of the group, and every month we end up with a couple hundred, 300, 400, 500 people on these online meetups. So as you're going, feel free to use the Twitter handle #RancherMeetup. If you're new, post your picture, introduce yourself, explain how you use Docker, how you use Rancher. I've been lucky enough to meet many of you around the world as I'm traveling, and it's awesome to finally put a face to a name. So please get involved. Join us on Slack if you haven't already. There's a slack.rancher.io is the public Slack. You can also ask questions and chat on there as we go. So join the meetup, get involved, and if you have ideas for topics, suggest them. We welcome guest speakers if you'd like to present on a meetup, show what you're doing, or you have a cool integration or some cool new product in the Docker ecosystem. We'd always love to have you come and talk. Okay, so today I'll do, as always, just a quick 2 or 3 minute overview of who is Rancher and what we do, but I will spend a couple extra minutes talking about DockerCon and some of the updates that came out of DockerCon. Then Shen is going to dive into Project Longhorn. He'll introduce it, go through some slides, and he and Sheng Liang will do a demo and sort of finish up by talking a little bit more about the architecture and what's going on under the hood, how we replicate storage, how we take snapshots, how we handle failures, how it works with Kubernetes and Swarm and Cattle. And then I'll just finish this up with a couple quick notes on Rancher 1.6, which is the upcoming release and that you'll see in the next few months. So just as a quick overview of Rancher, Rancher is a software company. We've been running these meetups now for almost 2 years. And in that time, we've grown a lot as a company. We're now almost, I think we're 65 people around the world. We have 3 main products. Rancher, which is a complete container management platform that's open source and used by tens of thousands of people around the world to manage their containers. Rancher OS, which is a tiny 50 megabyte Linux distribution. And Project Longhorn, a new thing we just introduced last week at DockerCon, which is really block storage designed to be delivered as a microservice And we'll talk a lot more about that, obviously, as we go. So what we try to accomplish here at Rancher is building really this complete platform for people to adopt containers easily and put it in production. And what that means is, from the OS all the way up to the platform and the orchestration, we make it easy to come in and deploy a simple platform to operate and run your containers. We make it easy to then manage applications. We provide things like catalogs and infrastructure services for those containers. And obviously in the end, the focus is on innovation. I mean, we want people to release quickly. So we do a lot of work to integrate with tools like Jenkins and GitLab and GitHub and other things that are part of the CI/CD DevOps cycle. At its core, though, Rancher is really the first container management platform designed to run on any infrastructure easily. That means we can absorb resources being provisioned out of public clouds, private clouds, on-premise resources like VMware, bare metal, and we allow users to basically consolidate those resources into environments. So an environment for Rancher is a cluster of hosts with an implementation of infrastructure services like storage, networking, security capabilities, and an orchestration tool. And Rancher supports our own distribution of Kubernetes. We support Mesos. We have our own orchestration technology called Cattle, and we've been supporting Docker Swarm. And all of that then gets managed through a management platform, which means you can connect it to your RBAC systems. You can plug in to whatever CI tools you're using to automate any of this stuff by talking to a central API, spinning up environments, launching services, and then exposing application catalogs to make it easy to launch and run your applications. For people who haven't been paying attention, last week was DockerCon, and it was it's bigger than ever. I think there were almost 5,500 people at DockerCon, up from about 3,000 the year before. So really impressive growth, continued growth of the ecosystem. There was, our booth at DockerCon was packed the whole time, and it was interesting because it was literally right across from CA, and it gives you some idea of, when CA arrives at the start of a technology conference, it usually means the market is real. People are really getting involved. Everyone is starting to develop products and roll things out. So it was really exciting to see so many people. We met, probably a lot of you were there, and for those of you who came by, thanks a lot. It was great to meet a lot of you in person. But there are a lot of interesting announcements. Rancher, we made 3 announcements. We announced Rancher OS 1.0. So Rancher OS, which is one of our projects, had been in 0.9 state for a while, and we finished a lot of work on it that we wanted to get done. So I'll talk about that for a second. We also announced a partnership with Docker. Docker and Rancher are going to work together to implement a new type of environment in Rancher that's a Docker Enterprise Edition environment, which is supported by Docker but can be deployed and provisioned within Rancher environments. And so we're excited about that partnership. And then Project Longhorn. So I'll talk a little bit about the first two. Rancher OS, for those of you who haven't tried it, it's really the smallest, lightweight way of running an operating system on your host that is tuned and designed to really run containers well. It's incredibly small, and because of that, it really only packages the Docker daemon, the Linux kernel, and a handful of core services that are needed to bootstrap the instant image and to give you a console and a handle full of other things. Because of that, it almost never needs to be patched. It tends to be rock solid and used in a lot of places where an entire Linux OS is overkill since you're running containers. It's been incredibly popular since we announced it. It's been out now for more than a year as an open source beta project. With 1.0, we're now offering support, so people who are running Rancher OS can purchase support contracts from us officially. And we're just, we've been really happy with the stability of the platform. It's just continued to be a very easy way to deploy and upgrade the Linux components for whatever you need for Docker. At its core, what that means is basically we run the Linux kernel in Rancher OS. We run then something called System Docker, which is the the first instance of Docker in our init system in the OS. That then boots up all the system containers, and then the user space is also it's a second Docker daemon. So we run a Docker daemon that's where we put all the user level containers. So it allows us to isolate system functions from the containers that are being launched by the user. But functionally, it really is just the kernel in Docker, so it's very easy to upgrade. And because we always stay on very recent versions of Docker, we can usually supporting the latest version, within weeks of it being released by Docker. The partnership we announced with Docker is exciting because it's really the first time we partnered with a company to implement an environment type that is supported by that vendor. So with this partnership, Rancher customers will have two options for deploying Swarm environments. They'll be able to deploy Docker CE, which is the new community edition of Swarm, and Docker Daemon, which they'll be able to run and use as open source tools and run on their own without support. But if they want support, they'll be able to get Docker Enterprise Edition Basic, which is basically the Docker Daemon as well as SwarmKit, the Docker networking, and all of the Docker functionality. And Rancher is going to be making that available as an environment type in Rancher. Customers will be able to buy support for that directly from Rancher or directly from Docker, and use those supported environments, just with confidence in production and knowing that Rancher will support any instances of Docker E running in there. Docker will address any bugs at the Docker daemon or Swarm level. And this partnership brings together kind of the ease of use and simple management of Rancher, along with all of Rancher's functionality at the ability to run multiple environments, along with the peace of mind of having Docker running Docker E. So where we've seen a lot of excitement about this is organizations where one or two teams may be using Kubernetes and other teams are interested in using Docker, and the company wants to implement a standardized way and standard platform for deploying container environments where everything is supported and everything has the kind of support necessary for production workload. There are also some interesting news from Docker at DockerCon that we just thought I'd talk about really briefly. Docker introduced the Moby project, which is basically splitting the open source project from the commercial project. And that split effectively means that it was very confusing. A lot of people, I think, were confused about this initially, but what it means is that the users will be able to really drive and modify the Moby project within the community, while Docker kind of runs Docker's own commercial product as the GitHub/Docker. I just got a note saying we're having some sound issues, so I apologize for those of you who can't hear me. Hopefully it's not impacting too many people. Let me just take a look and see if there's anything that I can do to turn it on. Is anyone still not hearing us?
It is apparently the dial-in that's working, but the computer mics and speaker option is not working. Start.
Interesting. Okay, let me see if I can fix the audio here as the administrator. Give me 1 second, everyone. I'm really sorry for this. Okay, I think I may have fixed it centrally. I don't know why it got turned off, but those of you who have been having trouble, you might be able to use audio now. Hopefully it's working for everyone. I apologize. Let's try this again. If you try, yeah, I think it's fixed. Okay, it's working now. Everyone's back on. Sorry about that, everyone. I have no idea why audio wasn't working, but it's working now for you. So for those of you who missed it, I apologize. We are recording all of this. You'll be able to see the part I discussed earlier as soon as we post it to YouTube in just a few minutes after the sentence. Glad it wasn't just you. All right, let me close this out. Okay, so I was just saying, what the Moby project is. It's really exciting. Basically, this is Docker splitting the open source project from its commercial product. That's going to allow the community to really drive what goes into the open source project, and really everything is there. This is, you'll be able to, everything from the Docker daemon up through Swarm and Compose are all part of the Moby project. Docker will then basically push that into their commercial product, which they'll be able to also put their own bits that they don't necessarily contribute back to the community into. So it's really I think the analogy was used many times of a Fedora to RHEL. I think that's the analogy that Docker is going for here. There's a couple other smaller announcements. They introduced Linux Kit, which is basically a toolkit for building Linux distros. It came out of their unikernels work that they've been doing for the last year. It's interesting because it allows you to come in and basically specify what you want in a Linux distribution and then build your own distribution with exactly the pieces and the components built in. We're taking a look at it, to see if it might help, with some of the work we're doing on Rancher OS. But obviously, Linux Kit and Rancher OS are a bit different. Linux Kit is basically a tool to go and build distros. Rancher OS is a supported Linux distribution that you can run, and it's more of a general purpose used for all sorts of different types of containers. Linux Kit would be used if you wanted to build a specific Linux distro just to run a specific container, a specific workload. So that's exciting and interesting, and we've been working with that team on that project. And then finally, they introduced another thing, which was called the Modernizing Traditional Apps Program, which sounded really cool. It's a partnership between Docker and a number of consulting firms. And basically, they say, we can come in 5 days and migrate your traditional .NET or JBoss apps to containers and give you a lot of benefits, both in how you manage those apps, how you upgrade them, how much density you can get on them. And so that's a pretty interesting program. I think we'll all be watching to see if that really drives a lot of interest. Okay, so that's really kind of our what I wanted to kick us off with. Glad we got the audio working in time for Sheng's session, which is introducing Project Longhorn. Sheng, are you there?
Yes, I'm here. I'm gonna share my screen. Could you give me the presentation rights? Okay.
Yep, you should have it now.
Great, thank you. Thanks everyone, and thank you for attending the Project Longhorn meetup. I'm really excited, to be able to talk about this. We've actually been working on this ever since really we started the company, and that was like 2.5 years ago. And this is a storage project. Storage is very, very difficult. If some of you probably work on storage, some of you use storage, but there's really, if you think working on a runtime or orchestration system could get complex, I just really think storage gets order of magnitude more complicated. And there's a fundamental difficulty in storage, which is you really can't fail anything. If you imagine if I issue a read and somehow the read doesn't come back, or then there's really nothing you can do other than failing probably the whole operating system. Or if you do a write, if the write doesn't succeed, then you wouldn't really know what to do afterwards. So really everything sort of hangs in the balance of storage working properly all the time, and that's. These days we kind of take it for granted, but building these large-scale distributed systems is quite an endeavor. And this is also container storage has always been a very hot topic. We wanted to work on it from the very beginning, and so do a lot of folks in the ecosystem, both the sort of the software platform vendors, management vendors, and a lot of storage companies, leaders in the storage space. Docker Inc. itself last year actually acquired a storage company called Infinite, and they have a very interesting solution that really combines, object, file, block, or into a unified scalable system. And of course, probably the best known open source storage technology is Ceph and Gluster, and both supported by Red Hat. And we've actually had quite a bit of an experience working with both of these technologies, both at Rancher Labs and also in our previous company. So we're big fans of those technologies. And in fact, a lot of things we did was kind of actually with Longhorn born out of our experience working with Ceph and Gluster. Then there's these big vendors like VMware, really successful vendors like Nutanix, and and storage established storage players like NetApp and EMC. I mean, I would say at this point it's fair to say, you know, everyone's pretty much developed a solid production grade storage drivers for their systems. And in fact, in EMC's case, they've actually really gone one step further. You know, EMC is a storage vendor, but they decided to develop a framework for storage, container storage systems. So they kind of went above and beyond just supporting EMC systems. Racksray is really a really nice system. It's integrated with Rancher, of course, but it's able to support, you know, Amazon storage or the other kinds of storage you have, and pretty much the potential is quite unlimited. Then when I see Rancher in production, not surprisingly, vast majority of Rancher users actually use Rancher on AWS. And on AWS, you know, probably the most popular persistent storage solution for containers is EBS and EFS. And you know, early on we developed Convoy driver, and then these things have since evolved into just Rancher, EBS, and EFS drivers, and they're very popular. And finally, I mean, this is that is a very good area of our collaboration with the community. There's just been a group of software-defined storage vendors that really, I mean, some of them been around for a while, like Nexenta, but some of them really kind of grew up with the container movement, like Portworx. I mean, they've taken a very interesting approach of putting storage software itself in containers, so that, you know, storage itself effectively is not just software defined, but they become as portable as the application itself. So I mean, I call it containerized storage. And Longhorn is also containerized storage. But you know, I just think this is a one big opportunity that the container ecosystem, container technology enables for storage systems. So hopefully that kind of gives you a good overview of where we are with containerized storage. I'm sure there are options, vendors, choices I haven't included here, but I kind of partly did this to try to, you know, I'm going to explain why, despite everything that's going on, we decided to start the Longhorn project anyway. Of course, you know, one reason is a couple of years ago when we got started, very few of these things actually existed, the drivers and some of the containerized storage systems. But we knew that was the way industry was going. But we also saw there might be an opportunity. And here's you know what was really going on. And I think it's kind of still the state of the art of the storage industry today. You know, as you know, storage, as these storage systems grow, the storage systems themselves really become very sophisticated and large-scale distributed systems. And one thing they all try to do is they try to be very scalable, in the sense that they would serve, you know, thousands, tens of thousands, hundreds of thousands, maybe in theory millions of volumes. To a large number of servers and containers. And usually these storage systems, I mean, I just happen to use Ceph as an example, but they all kind of pretty much work the same way. You know, are built on a dedicated group of servers, either that, or maybe in some cases, in a hyper-converged scenario, they'll be with Nutanix or vSAN, they'll be built directly on the compute servers. So storage systems, of course, by definition, is also a distributed system. And this is this is actually not an easy system to build. That's why Ceph has been around, I think, for more than a decade, and it's not uncommon for that it takes years, a decade for a storage system to really mature. And if you actually look at the amount of demand that we put on these large storage clusters, it's quite incredible. EBS, AWS EBS has far exceeded the scale. It's got more, probably, I don't know how many, maybe billions of volumes. But let's just say even in a modest-sized, container or cloud storage system, we'll say just 100,000 volumes. And let's just say each volume, somehow it should be designed for just 100 IOPS and 100 megabyte per second kind of a throughput and IOPS. Then if you just look at the aggregate IOPS and aggregate throughput, it's absolutely mind-boggling. And like I said in the very beginning, storage system is hard, right? So every second, 10 million operations are taking place potentially, and 10 terabytes of data is transmitted. If there's just one mistake or there's one error, basically that volume will be broken, and the contract between the storage system and the client is broken. And storage systems are very smart. They're kind of designed to recover from network failures, disk failures, host failures. But one thing that personally I've always had problem with was none of necessarily the hardware failures. In most cases, it's the bugs and issues in the storage systems themselves. And so I've personally had to work with clients when their large-scale storage clusters effectively crashed due to a bug, and it took a long time, much longer than it's acceptable. Say counting days to actually bring these systems back, and in some cases they led to lost data. So just I would say just like any very large-scale systems, it could kind of get pretty difficult. So that's kind of what and of course you can solve these. I mean, these problems are not unsolvable. It just requires a lot of expertise and a lot of solid engineering. But we looked at it and said, we could try something else, at least for a certain type of storage systems. As all of you guys know, in the cloud or with containers, there are really three types of storage systems. There's file storage, there's block storage, and there's object storage. So I think object storage really functions more or less like a scalable web application, and it's it's I think it's relatively a well understood paradigm right now. So we figured that that problem seems to be on the path of being addressed, and you have on one hand large scale object storage systems like Swift, or you have really simple to use small scale object storage systems like Minio. They're all very, very interesting. Or you can just have simple key value stores like etcd or MongoDB. So all these are kind of object storage systems to some degree. So we feel like that problem is fairly well covered. Then on the other extreme is a file system. So distributed file system is actually pretty difficult, and we've been working with folks like at Quobyte and NetApp. I mean, these are clearly experts in working on distributed file systems, and we just couldn't really figure out a way to further simplify the problem than how these guys have been working on. Then what's in the middle is block storage, and it turned out that block storage is very popular. It's still very popular these days, and when most people talk about stateful containers or running databases or running etcd, I mean, they're really talking about having a block storage like AWS EBS, and there's a huge amount of opportunity there, and there's actually something we can do to make things a little simpler. So one area, I kind of got some inspiration from is a lot of you, if you're in storage, you probably remember this company called Fusion.io that was later acquired by SanDisk. They started, I think, more than a decade ago. But when I first saw Fusion.io, they were really the company that made SSD popular in the enterprise, and they basically just had a PCI-based SSD card. So a lot of people early days used it to run databases, and they got very good performance. And of course, if you have a PCI card plugged into a host, it's not really HA, so clearly, it's not enterprise grade. And then I thought what some of the early Fusion IO guys did was actually pretty interesting. So they just kind of create a very simple solution. So they use 2 boxes, and with 2 PCI cards, use a very high-speed interconnect. I think at the time was like 10 GB, then it became 40 GB. So with that, with a direct fiber connect, they essentially kind of create a network rate, and they're able to run, and then you it's a very simple system, and you're really able to get very high performance and high reliability, and a lot of the banks and Wall Street firms is actually able to run Oracle databases on a configuration like this, and it's very simple. I mean, this is actually server-side storage, not network storage, and they're doing this, but they're kind of just doing this for one volume, really, and one PCI card, and it worked pretty well. So again, this is like a solution from 10 years ago. So kind of always left a bit of an impression on me that this maybe the block devices, we can kind of do it much simpler, because fundamentally these block device volumes are not really shared across multiple VMs or multiple containers. So maybe a simple network RAID-based solution could work better. And by the way, feel free to raise your hand and ask questions if I'm kind of going too fast here. So otherwise I'll just keep going. So what we got the idea from is we said, like, instead of say running one controller for 100,000 volumes and design a sophisticated controller that has to be a distributed system by itself, or at least an active passive system, and a single bug in even though the controller is designed to handle all kinds of hardware failures, but a simple bug in a controller could potentially bring down the whole controller. So instead of doing that, maybe we could, essentially write a separate controller for each one of the volumes, and now we end up with a lot of controllers. But actually, I think industry as a whole is getting very good at, orchestrating large number of things, because that's what, Rancher, Docker, Swarm, Kubernetes, those systems are designed to do. So we kind of took some ideas of that, and that was really kind of the genesis of Longhorn. Basically, the whole idea is, imagine, you're running a large-scale cloud deployment or container deployment, and you need a lot of volumes. Let's just say you need 100,000 volumes. You could do it by buying or setting up a centralized storage cluster, storage servers, storage controller, or you could have 100,000 of them, and now you have a challenge of how to really manage that, because they're going to each individually break, but I said we have orchestration tools to deal with that, and really we're taking advantage of the fact here that these block storage volumes are really logically isolated, because a block storage volume, the way AWS again is the company that set the standard, that the way they designed it very early on, EBS volumes is it's only serves one virtual machine, right? So that kind of became an industry standard, very different from how storage volumes worked early on, where you have clustered controllers and stuff like that. That each volume has to be mounted read-write to multiple hosts. So this is sort of give us a way to really decompose the problem to the extreme. So that's really the thinking behind Rancher. So if you kind of look at the way Rancher works, assuming you have Longhorn works. This is the thinking behind Longhorn. So assuming, let's just say I have 2 hosts. Each host has a number of disks. I kind of use a spinning disk icon here, but they certainly could be SSDs, and has some CPU and some memory resource. Let's just say I create a container on one host, and this container has a Docker volume. So what Longhorn would do is we would actually create a controller. It's almost like a microcontroller just for that volume, and then this controller, obviously we don't, for the sake of reliability, we don't want to run we don't want to place the volume just on one host. So this controller essentially works like a RAID mirroring controller built on 2 network disks, and they run on 2 separate hosts. If we only have 2 hosts, that's how it's going to get scheduled. So let's just say if I have a second container, it's going to have its own completely independent set of replicas and controllers. The third container, again, would have its own set of controller and replicas. And so now think about that. With Longhorn, we actually manage these controllers and replicas as containers as well. So imagine if I create a container, it has 1 volume, we'll actually end up creating 3 additional containers just to serve that 1 volume. We can do it because, again, like containers are really lightweight and they're very efficient. And this is, what I mean by I mean, different people say microservices mean different things, but in my view, this is what comes very close to the essence of microservices. So you could think about it as a storage systems built using containers and microservices. That's sometimes we explain Longhorn that way, and I think it's kind of accurate. Of course, if I have so many controllers and replicas, we have a huge problem. We're going to have a lot of these containers lying around. We're going to manage their life cycle. We're going to have to make sure they're healthy. If a host crash, maybe we have to recreate the replica. So we really have to manage these things, and that's where we use container orchestration systems. That's where the control plane
Shen,
comes in.
Before you jump on, there was a bunch of questions once
Sure.
you started getting into the architecture that started firing in. So the first question came from Frederick. He said, "Do the disks need to be dedicated to Longhorn, or can it be a host folder or something similar?"
Yeah, it's a great question. It's just a folder on the host. Dedicated. In fact, that's the only, in the current version of the Longhorn, that's the only thing it supports. But we are actually adding support for dedicated hosts. It's one of the upcoming unfinished work.
Excellent. And then there was a question from Ronnie. He said, "When is Longhorn available?"
Longhorn is, we announced it, and you can kind of download it and run it, but it's clearly not ready for production. And I think it honestly probably requires a few more months of baking. I expect it to really kind of show up. I mean, I'm going to do a demo, and you'll see what it can do and still what it cannot do. I'm hoping it becomes production grade like second half of this year, maybe toward the early part of in some sort of a beta deployment early part of second half. So actual production deployment maybe later part of second half by end of this year. That's my sort of realistic expectation is. But again, a lot of that also depends on your actual use cases and the actual feature set you're going to use. I'd say internally at Rancher Labs, we actually have a little bit more aggressive plan to actually leverage Longhorn ourselves, but because we can fix things a little quicker for ourselves.
Okay. Why don't you jump in? There was one more question Ronnie asked about, is the replication asynchronous?
Synchronous. Yeah, great question. We just kind of kept it simple. It's every read is a read from one of the replicas, and every write is just synchronous replica. But I guess it probably doesn't need to be that forever. But for now, that's just simpler.
Excellent. Is there a roadmap for Longhorn? Jeremy asked. Is that published on the GitHub page?
It's just still coming together. I'm going to talk about it a little bit later on in the slide. But we really need to put this up. Again, some of that, we love to hear your feedback and what you really care about. File issues, file tickets, and we'll respond. Where this is a. I mean, I think we really love to run this as like a community project, and not just with developers. If you're a user as well, that's totally fine.
Awesome. Yeah. Why don't you keep moving?
Okay. So this slide kind of really shows how the data plane works. Data plane is in the sense that data plane in storage is basically when when the Docker volume writes a byte, you see these arrows. That's basically what a write operation triggers, right? If I write something, it's written to the controller, then it's written out to the replica, and eventually it's written to the disk. So that's what the data plane is. But we got to manage all these controllers and replicas. How is that managed? So it's actually from a control plane point of view, it's a little different. So from the top to bottom, so as a container, in a container system, you don't, in most cases, you don't even really see volumes. All you see is like a Kubernetes or cattle or swarm cluster. And then these cattle, swarm, Kubernetes systems, they have a volume plugging API, or in Kubernetes case, it's called Flex Volume Plugging API. And by the way, Kubernetes guys are actually working on a new volume plugging API. I think it's called Container Storage CSI. You know, so I think Docker guy also has a new volume interface, driver interface. I just heard about it at the DockerCon. So you have these plugin interfaces, and for Longhorn, we basically need to write a volume plugin according to what these higher level orchestration systems need. And then the volume plugin, Longhorn volume plugin, either for Docker or for Kubernetes, kind of translates what Docker or Kubernetes need into a simple set of Longhorn APIs. And Longhorn API is very simple. Just create volume, delete volume, that kind of stuff, right? List volume, get attributes, and it gets passed on to something we call Longhorn Manager. Longhorn Manager is think of it as it is actually the orchestrator of all the controllers and replicas in the system. So Longhorn Manager is actually a container that runs on every host in the cluster. So it's like that's basically it, and it does some magic, to orchestrate everything. It's built on a Longhorn Manager requires a key value store. So here I said etcd. It doesn't have to be always etcd. If you integrate with Rancher, we're probably just going to store that in the Rancher database, and you don't need another etcd. And then the Longhorn Manager itself will then go ahead and manage all these controllers, and then controllers actually manage the replicas. So that's kind of how roughly the control plane works. So as I give demos and explain this thing, it'll hopefully become a little bit more clear. So before I really go into demos, I kind of want to explain, give you another high-level view of because we keep talking about Longhorn and replication. It looks like it's almost an enterprise-grade storage product, but it really isn't. So I want to explain what Longhorn is designed to do, and some of the things, even though strictly speaking Longhorn could be made to do, but we actually do not really plan to do them. And a lot of that is actually based on our thinking where the storage industry is going. Storage industry has really come a long way from spinning disks to SSDs. But a part of storage industry that's honestly the most fascinating to me is the size of SSDs. There was a time when we all thought SSDs are for fast, small disks, and spinning disks are for capacity disks. But in the recent years, this seems to be changing. I mean, this is an article actually from a long time ago, from last August, almost more than 8 months ago, and I think at the time Seagate was exhibiting. I don't think it's shipping yet, but it's mind-boggling, right? 60 terabyte SSD, and it's also interesting. You can see the hard disk manufacturers really taking the lead here. It's not even like they're being disrupted. It looks like they're disrupting themselves. But this is absolutely astonishing. With 60 terabyte SSD drives, you only need 17 of them to reach 1 petabyte, which kind of makes me think. Imagine we're probably not really that far away from 1 petabyte SSD drives, because SSD drive seems to be one area that Moore's law still seems to be working. So and that would just fundamentally change. We've been thinking, if we're kind of designing Longhorn now, we should really have that stuff in mind, and that kind of brings to what we really do about Longhorn. And I think, Longhorn needs to focus on things like simplicity, reliability, and performance. Usually reliability comes with simplicity, and performance, obviously, SSD, that's absolutely required. And I think, with this kind of microservices kind of architecture, we're actually ideally suited for that. So I explained the controller replica framework. So controller is a mirroring controller, and that's just how we do it today. I mean, we could probably do advanced RAIDs at some point too, but let's just say it's a mirroring controller. It does a rebuild, and we don't have encryption today, but that could be easily added. A lot of people kind of like that. Imagine if you have encryption, and then you can use Longhorn on a public cloud for containers. Then you can essentially have some control about your own data encrypted without worrying about the cloud providers, whatever additional protection mechanism they also give you. So those are pretty simple things we can kind of implement in the controller. At the replica level, we can implement things like snapshots and backups, and I'll explain how we do that. We basically implement the Amazon EBS style semantics, a little bit more general than that, but you can basically take arbitrary snapshots and you can back up snapshots pretty efficiently, incrementally into a secondary storage, either NFS or S3. So or object store, S3 like object store. It doesn't have to be S3. And then at the replica level, we can also easily do QoS because we're really leveraging a lot of Linux features because actually storage QoS in the sense of rate limiting and IOPS limiting has been in Docker for forever. So we really don't even have to do anything to enforce that in Longhorn. So that stuff is actually a lot easier than you think as I go through the rest of the detailed design after the demo. But you should also look at the long list of things we actually don't support. The list is even longer than this, but I kind of highlighted a few things. Probably the most significant thing we don't support is controller HA. And it turned out we don't really need to support it because, for a couple of reasons. Because the controller only works for one volume. So if it crashes, it hurts one volume. But that's still not acceptable. Imagine if the volume is enterprise grade, how could you crash the controller, right? But then if you think harder, the controller is a relatively simple piece of software that's running on the same host as the container itself. So there are a lot of things that could happen on that host. I mean, imagine if Docker daemon crashed. Imagine if your kernel crashed. And those are far more sophisticated software than controller, right? Imagine if your network driver crashed. So controller becomes just one small bit of a thing that's running on the same host. So that's why for practical purposes, it just does not even need HA because again, it's tied on the same host to one volume. So that leads to dramatic amount of simplification because then with controller HA gone, some of the related things that we also really don't need to consider, like multipath, for example, in traditional storage systems. So it's because you're right now the path from the volume to the controller is a Linux domain socket running on the same host. Yeah, it could go wrong, but if a Linux domain socket stops working, I mean, your Docker daemon is probably also screwed up, so you probably would need to reboot the host anyway. So it basically really simplified a lot of the design. Then there are a lot of storage features, so the traditional storage features, tiering, incredibly complicated. I mean, that's a great feature. Like I was so blown away. I remember the first time I set up Nutanix, you kind of plug in SSDs, you plug in, hard drives and whatever capacity you want. It kind of goes in and automatically figures out how much you really have, checks the speed of these disks, and then intelligently places all the workloads so they effectively get the speed of SSD and the capacity of the hard drive. So this is all really good, but also really complex, right? And if in the world of 60 terabyte, 1 petabyte SSDs, I mean, I think we're just not going to worry about this. Striping, that's I think I'm not just talking about RAID striping, but maybe more generic way of a lot of times when you build these storage systems, you really have to kind of take, a lot of storage systems are built with the assumption that you take one volume and you break it apart into a lot of small chunks and you distribute them into a lot of disks. And that's really not that hard, but it generates a lot of metadata. And that you kind of have to manage. You have to remember where everything is. And when the number of volumes really grow, the scale we're talking about, it kind of becomes an issue. And again, in the world where a disk itself is an SSD and it has 60 terabytes, and you probably, I mean, it's got enough capacity that most of, and it's got enough IOPS, probably you can just fit a volume on SSD. So we don't do striping right now. We could probably add it in the future, but this is again something we simplified. Dedupe, I think very few modern enterprise storage systems can get away with not doing dedupe. It seems like table stakes now, but again, think about 60 terabyte SSD and the amount of CPU power you have to take just to compute checksums. You don't really have to do it. So Longhorn has a bit of a dedupe, I'll explain later, but that only happens during backup when we store things in secondary storage. But we also do it in a very simple-minded way, but we don't really dedupe things when we store stuff on primary storage. And compression, that again, compression is okay, but it could also lead to fairly complicated, now the size is essentially non-deterministic and it just complicates things. And again, in the world of large SSDs, we feel we can, maybe we do, and then it requires CPU. So, and we already have trouble. Like when I run Longhorn benchmark, CPU is always the biggest issue, biggest bottleneck already. So we just decided not to support that, at least for now. So you can see what Longhorn actually does and what Longhorn doesn't do. So Longhorn is an open source project. We announced just a week ago, and it actually even before it was announced, some folks in the community managed to find it, and actually they managed to use it in their projects. But since then, there's been actually a lot of interest, so we're very excited. So I'm just gonna show you where it is and what it looks like. So this is the Longhorn GitHub page. It is the Longhorn repo itself is really just almost like a gateway. There's no real content here other than just README and some issues. This is the place we capture the issues. I think a lot of the real code is in Longhorn Engine, Longhorn Manager, Longhorn UI, that kind of stuff. But this stuff does tell you, it has a link to a blog that describes the design in a lot more detail. But the most important thing here is it shows you how to set it up. It's really quite easy, especially if you do a single node setup. For now, like we really want to make sure that Longhorn works everywhere. So we didn't even create a strong tying between Longhorn and Rancher. You can just run Longhorn anywhere Docker runs. And we're gonna build of course we're gonna build a lot closer integration between Longhorn and Rancher. We actually already have that, but we haven't really tested it and released it yet. But the easiest thing to do is just set up a single node Longhorn environment, and then you can start using it. So I have I have a environment set up right here. This is just a single node environment, and this is the and what I've kind of run the commands already, and I've got a whole bunch of containers already running. You can see everything's on the same node. So I got etcd, which is the key value store used by Longhorn Manager. We have Longhorn Manager. Longhorn Manager, again, is really the container that does the real orchestration. So we have one instance of it on each node. And then this is the Docker volume driver, Docker volume plugin for Longhorn. You also need one instance of it on each node. That's automatically created by the Longhorn Manager. So really only like etcd you need to set up yourself, and Longhorn Manager you need to set up yourself. Longhorn UI, this is if you need the UI, you kind of just install it on any node, and you'll get UI, and you can set up as many UI containers as you want. So I've already got one container run. I've already got one volume running. Just I think this volume itself actually has one controller. It's called, I think it's called test. The name of the volume is test. So it's test, and it's got 2 replicas. Because I only have one node, actually both replicas get scheduled on the same node. So there's no real redundancy here, but but it's easy for development and troubleshooting. And this volume is actually is backed by this controller, and the way exposed is actually exposed as a Linux kernel device. It could be exposed as an iSCSI target as well, but Docker really just wants a Linux kernel device, so it's mapped to dev Longhorn, and you can see this dev Longhorn test. That's just the name of the volume. So I've only got one. I've really only got one volume here. So Longhorn has a really simple UI right now, which we're gonna enrich over time. We're actually adding a whole bunch of stuff like stats and logs and plots. But for now, what you can see is that I've got one host, I got one volume, like I explained, and I'm just connecting to that host port 8080, connecting to that Longhorn UI container. So on the host, I've got, this is the name, I just named it Ubuntu. And it has 2 replicas, running right now. I've really only got one volume going on. And the front end for this volume is dev Longhorn test, as I kind of showed you before. I created last night, and it's 30 gigabytes. So if I kind of click into this volume, you see a little bit more information. This volume has 2 replicas. At this point, both are healthy. This is the stuff I like. I say we have pretty sophisticated snapshot mechanisms. You can really take arbitrary amount of number of snapshots. So right now, this live volume is right here. It kind of actually works a bit like VMware Workstation, link clones. If you guys have worked, and I can actually revert the live volume back to any previous snapshots I've taken, and it'll actually preserve the tree structure. It wouldn't throw away. And I can, I work on this a little bit. Maybe I take another snapshot and I can bring it back. And for every snapshot, I could take backups. I could back up the content of this snapshot to secondary storage. Backup is very efficient because it only backs up absolutely what needed to be backed up, and I can restore it later. So then the final thing is what a lot of users really want is not just manual snapshots and backups. They like to have the ability to take recurring automatic snapshots and backups. So this is a really powerful capability of Longhorn. I could say I got database here. I want to take a snapshot. I want to take a backup every day at a certain time, or I want to take a snapshot every year at a certain date, certain month, certain time, or I want to take a backup every minute. You probably don't want to do that. So there's I want to take a snapshot backup every week. So I'm gonna maybe I just see what happens if I kind of create a job and I actually take, because as we're talking, and I'm gonna just maybe keep 2, okay, or maybe keep 3. Let's just see what happens. This is where my live volume is, and I'm gonna say I'm gonna actually start taking minute snapshots, and I'm gonna keep 3 of them. So so let's see what happens later. I've got this volume started. This is like this volume is actually kind of manually created through this Longhorn UI, which effectively calls the API. I can kind of create another one, and once it's created, it's in kind of a detached state, and I have to attach it to a host. I've only got one host to attach to. So once I attach to a host, it shows up as a Linux device. Then it could be used. It could now I could actually just use it. And, now you actually see it. You can actually format it or whatever, and you can I guess I can mount it. Let's just say so now I have a volume in there, right? So I'm just gonna unmount it.
Shannon, I have all sorts of questions. The questions I haven't want to interrupt you because you're kind of in a flow, but there's just like
please do. Please do interrupt me.
Yeah. So let me just take. I'm trying to go up through these. I apologize to everyone for not answering all of these great questions that have been coming in. Let's start with Ed. Ed just asked a question. He said, "Are there any performance or latency stats available for Longhorn?"
Yeah, we haven't done a whole lot. There was an organization called OpenEBS. They actually performed some measurements, and it was not bad. So you can find a link to that article in this blog, actually. It's also like initial testing. To be honest, we haven't done any performance work at all. But I tell you, the design is so simple that it doesn't, because we don't really do. I mean, I'll explain. We don't really do very much. That's why. I think there's definitely room for performance tuning, but I also think just by virtue of design, it's probably unlikely we're going to find opportunities for orders of magnitude kind of improvements.
Okay. There's another question Ronnie asked. He said, "Is there a plugin for Rancher? Can I use it together with Rancher?"
Yeah, that's ironically that's the first thing we got it working, but we decided to kind of write it a little bit in a better way. So right now we actually kind of deprecated, and we're creating a new one. So there's going to be one soon. Rancher fundamentally uses Docker volume plugins. So as I was kind of explaining it earlier, this is Rancher actually follows all these stuff will be supported because Rancher supports Kubernetes, supports Cattle, supports Swarm, right? So a Rancher plugin basically also means it has to be a Kubernetes plugin. It also has to be a Swarm, Docker volume plugin. So we actually have all of that stuff, but they're just not quite mature enough. So right now we decided to just really whip the first, basic Docker volume plugin into shape first, and then the Rancher support should be there within weeks.
Awesome. There's a question from Axel. He said, "Can you resize the volumes during use?"
No, right now we haven't really done it. But I will give you. There's really no reason we can't do it. There's something more amazing we actually can do than just resizing the volume. So I will kind of explain it a little bit later.
Oh, cool. There was another question from Dustin, and Dustin said, "Will Longhorn support console for a key value store?"
Oh yeah, any key value store we should be able to do. Console, etcd, MySQL, or whatever, DynamoDB. It doesn't really matter.
Awesome. There's another question that Mark said, he said, "What is a physical implementation of a replica persistence? Is it just a file on the local file system, or is it allocated from local block device, or something else?"
It's a sparse file. I'll get into that right after the demo. We'll do a deep dive. It's a sparse file, so we get thin provisioning, but it's just a Linux sparse file.
Awesome. And then David asked, he said, "What sort of speed for network I/O are you thinking about with Longhorn?"
Yeah, so network turned out to be a bottleneck for Longhorn because obviously in a situation like this, right? Like both the read speed and write speed is pretty much limited by network. So the nice thing about Longhorn is because the logic is pretty simple. Like the software is pretty resilient. So obviously you're not going to be able to write or read any faster than what the network can supply. But it'll use as much and we actually can do QoS with containers, to some degree. So, but it's just not gonna. But network. I mean, if you have sufficient network, it'll just saturate it. So if you don't have sufficient network, it'll saturate it. If you have sufficient network bandwidth, then it just will not be a bottleneck. So that's just the law of physics.
Thanks. There was a question from Jerome. He said, "Can Longhorn be used as a Kubernetes PV/PVC, or used as read-write many, and used as read-write many?"
What's read-write many? I'm actually not sure. Kubernetes PV, yes, that's exactly what we're working on. Yeah, I'm not a I'm not familiar enough with that aspect myself. I just haven't coded that.
Okay. I just asked him if he could clarify read-write many. There's a question from Gurmeet. He said, "What can be the replication factor of Longhorn volumes? 2, 3, N? What's the option?"
Anything. I personally tried 20, just as a stress test, but I want 100, whatever. But it actually works.
Awesome. And then Michael Guerrero said, storage companies like Nimble are writing plugins for Docker. Wouldn't that be more next gen, or what do you think of how does this compare to something like that?
Yeah, that was what I covered in the first slide. I mean, I think that's just the state of the art today, and what we're trying to do is not just one Nimble storage controller, but we're building a lot of these little ones that are in turns, orchestrated by Kubernetes or Cattle. That's what we're doing.
Great. And there was Axel had a couple other questions. He said, "What happens to the using container if the controller dies? Does it die with it?"
If the controller dies, the using container will not die with it. But at that point, to be honest, there's really no way to recover the volume, because this is kind of equivalent of this is like in the with virtual machines, sometimes you lose the volume, like the kernel will dismount the volume and mount it read-only just to prevent further corruption. Something like that will probably happen. But that is really the hardest part of storage is this whole data plane. This data plane really can never be broken. If this stuff is broken, like above the controller can never be broken. Obviously, an individual replica could be broken. That's the whole point. But above the controller, if that thing is broken, the volume basically host. I mean, you at that point you're probably better off, creating a new volume from the backup, or create a new container altogether.
Got it. There's just tons and tons more questions coming in. So why don't we keep going through some more questions, and I'll let you dive into the rest of your demo. Jo asks, "Can backup snapshots be saved to S3? I think you covered that. Yes, they can. Can you also reiterate, Mark asks, what is the physical storage for replica persistent? Is it a local file system?
Yeah, it's a file system. It can be. I mean, we don't really care. It's a file system, but these days a file system may not be a local file system, right? It could be like a network-mounted disk, or it could be, say, it could be a file system on a VM which is backed by a EMC SAN array, which is network storage. So this is really any kind of file system. It's fine. Or you could have just mounted the EMC SAN into the host, and then created a file system on it. That would work too. So it's really any kind of file system, Linux file system that supports. I think it has to support sparse files.
Royer asks, once a volume is attached to a host, will Longhorn make the volume accessible to the cluster?
Once the volume is attached to the host, no. The volume is only, so that's the thing with the volume in a detached state, it kind of just floats in a cluster. Volume, when it's used, so that's the fundamental property of block storage, right? can only be used by one. It can only be really, strictly speaking, written to by one host at a time. So like I think AWS get one level further and say it can only be used by one host at a time. So that's how Longhorn works. When it's attached to the host, then it can be used by that host. So imagine if it's attached to the host, then it's being used by a container on that host. So a typical persistent volume demo you've seen is then people would say, I'm gonna kill the host or kill the volume. Then I start the container on another host. Then what's going to happen with Longhorn is you're going to just attach the volume to this other host. Then the other host will be able to start using the same volume.
Awesome. You mentioned that you tested Ubuntu. Erkin asks, will it support CoreOS or Debian hosts or other Linux distros?
Yeah, there's no real. We just haven't tested everything, but yeah, it'll work everywhere.
Yeah, we'd love help on that in the community. If you want to run it on something else, please test it away and file issues if you're having issues and help us fix them if there's anything you're seeing, because obviously it's getting harder and harder to test all the different Linux distros. Oliver,
we actually put a lot of thought into this. By design, we didn't use early on. We required the way we did it. This front end, I'm going to explain a little bit later. We required some kind of a kernel patch that wasn't widely available. So we've actually since moved away from it just so that it can work everywhere.
So Oliver asked a question. He said, "What happens to a stateful app if a replica fails? Is there any interruption?" So if a single replica fails?
A single replica fails, there would not be an interruption at all. That's it should be able to rebuild, right? So the Longhorn manager working with the controller will just rebuild the replica.
Laszlo said, do you have a recovery method when somebody deletes a volume carelessly? I'm assuming that's the backup.
Backup, yeah. And
then another question from David. He said, is this intended only for hosts within Rancher, Kubernetes, Cattle, Mesos cluster, or can this be used as storage for hosts, a storage host, and then connect my Kubernetes cluster directly to it?
It's possible. I think Longhorn is really. Let me put it. Longhorn could really be deployed on any existing Kubernetes cluster. Yeah. So that should be. I mean, even the demo I'm doing right now, there's really no Rancher running. So yeah, it should be the latter.
Okay. How do we ensure data consistency? Aram wants to know.
How do we ensure data consistency? There's actually really not a whole lot of magic, in this picture probably. It's basically just replicated synchronous writes. You just don't want to declare success until both writes are successful. So the fundamental contract of all of these storage systems is basically when you do a write and you respond it with acknowledgement that write is successful, you better retain the data. Like you better actually finish the write. And then when you actually do a read, you better read something back that's reasonably consistent. Actually, that read-write consistency is not that strong in many cases, but without a barrier. So as long as you kind of satisfy, but the most important thing is really write. When you actually declare success on write, you better make sure it's actually taken place.
Got it. Axel asks another question. He said he's trying to understand how Longhorn actually works. Is it a real block storage like EBS? Then it would need to have a file system on top. If not, then are we kind of emulating it? He's wondering how the data plane works there, and
Yeah, great question. It's like EBS. You need a file system on top. So I was in my demo. That was exactly what I was doing. I actually remember I created test2 and I actually put a file system on top. But because I'm actually doing it manually. myself, but in most cases you actually don't do that. So if you actually create a volume, say through a Docker container, like this is another way. Like remember, I kind of went through the UI and created a test2 volume. So now I'm going to create a vol1 volume, but now I'm actually just using Docker command line, right? Or in the future you could use kube control or whatever. So I'm creating a volume called vol1. So if you see here, the you know, if you see here.
Because the
Oh yeah, it's not, sorry, it's not mounted yet, right? So I have to actually I actually have to start the volume. Yeah. So once I start the volume, this is just standard Docker command. So now it's actually mounting the volume. It's formatting the volume. So and mounting it into the container. So this is actually a file system. So if I come over here. You know, you see it. It's created, and if you you know, look at here. I mean, you see this file. It's 100 GB because that's the default size for our Docker volume driver. And I didn't really create directly with the Longhorn API. It's actually created by our Docker volume plugin. So you know, remember I was explaining these days. So this thing essentially went through this middle path, whereas earlier I created volume through the UI. So that's what's going on.
Awesome. Shen, do you have some more demo that you want to cover? Because I've got like another 15, 20 questions that we could go through a little more demo, and then. Oh
yeah, let me finish the demo. I mean, yeah. Hopefully finish the demo, and I really still have a lot of slides, and you know, and I'll finish the demo very quickly. I mean, there's just way too much to cover. I think I'm gonna kind of show you, or maybe not this volume. Let me look at another volume. What's the volume I was taking? Some. Yeah, this is a cool volume to look at because I remember I was taking recurring snapshots. So look at that. It's I said retain 3 snapshots. Take it every minute. So exactly, you see one snapshot a minute ago, 2 minutes ago, 3 minutes ago. So snapshots and backups are taken like exactly on the dot. And then if you do a backup sometimes take a while to finish, but you always guaranteed. You know, I'm actually backing things up, and you know, you can go to backups. Early on, actually, I created some backups for this particular volume, and I can see it, and I can recover from it. That's another vol1, not the same vol1 as I just created. So I think I mean, that's probably there's more stuff to be seen. I mean, I could show you, like, if I kill a replica, how it recovers and stuff like that, but I'm just not going to do that, just due to lack of time. So I'm going to just kind of keep going and kind of get to the real meat of the talk. So we're really just getting started. So now we're going to look at how Longhorn is actually implemented. Okay. So the first thing is these Longhorn replicas actually just stored as Linux sparse files. You know, one thing about Longhorn is we really try to utilize existing Linux functionalities. I think, you know, Linux these days is really not just an operating system, but it's also a networking operating system. It's really also a storage operating system. It's got so much capabilities already built in. So just by using sparse files alone, we basically kind of get snapshots and thin provisioning for free. So and we just use differencing disk. We use chaining, you know, differencing disk to implement snapshots. Very efficient. The only problem with differencing disks is read could become slow. So imagine I've got, like, let's just say I've got 4 differencing disks here, and this is the live data. That's the most recent. It points to the last snapshot, then points to the older snapshot, then it points to the older snapshot. And obviously, let's just say if I read from block 1, obviously it's in live data. But if I read block 0, it'll be in the snapshot, right? So what we basically do is you have to kind of do the lookup once using Linux metadata, Linux spouse file metadata, which is all actually really nicely done API. But after that, we just store this information in a read index. So it becomes actually very efficient. This index gets built up lazily on demand as you actually start to read stuff. And then let's imagine you do a write. Like if I actually write to block number 5, then what happens is further reads for block number 5 shouldn't go through this green link anymore. It should just go directly to live data. So every write essentially could trigger an update of the reading that. So it's just, this is very simple algorithm, probably no more than a few dozen lines of code. And that's it. That's, here you already see thin provisioning, you see efficient read, and you see snapshots. So that's really how Longhorn implements it. Next is we implement backup. So now in primary storage, we already have this difference in disks. And the nice thing with Longhorn is we do incremental EBS style backup of any snapshots. So think about it like if I back up snap 2, we would actually have to also back up a block from snap 1, because when I back up snap 2, I really have to be able to recover the entire disk at this exact state of snapshot, right? So essentially this blue block from snap 1 will get backed up as well. So even though snap 2 has only 2 blocks in the differencing disk, in a backup it would actually have 3 blocks. And snap 3, it only has 2 blocks as well, but actually in its backup it actually has 4 blocks because this green block is also valid in snap 3, because when I read this particular block, you can't tell me there's no data. There's actually data. Likewise, if I read the third block, you should give me the blue block. So that's kind of how backups are built in secondary storage. Now, one thing is in primary storage we use 4 kilobytes blocks, but when we do the backup, we actually round these things up to 2 megabyte blocks because we don't really want a lot of little files to be backed up, and because at backup we also do compression and dedupe, So the way backup is stored is we actually store all the files for the backup according to their SHA checksum, and this is a particular this is actually how like 2 backup snap 2 and snap 3 in the previous slides are stored. So like we store some this is in S3, what it would look like on an NFS server. I have some metadata file for the volume itself, pretty simple. Then I have a metadata file for each backup, and really these metadata files pretty much points to the blocks because they can share the blocks. Now one nice thing about it is because these blocks are essentially content addressed, so you get deduped by default, at least for blocks coming from the same volume. But then the flip side of that is when we delete a backup, we don't really know. We can't just go ahead and delete all the blocks in a backup because like if we delete snap 2, we can't just delete this blue block because it's still being used by snap 3. So we're gonna have to do periodic GC and stuff like that to clean up the backups. We have to read out all the backup metadata and then make sure only really we delete the blocks that's absolutely not being used by anyone. Now this is probably a more complex scenario. This is really but for folks doing storage, this actually should be pretty straightforward. Assuming that we have a replica that's gone bad. Let's just say a controller used to have 2 replicas. Now 1 replica has gone bad, and we have to get rid of it. And now we have to rebuild it. We have to actually insert a new replica in. And let's just say this controller actually has 1 snapshot. I just kind of want to make it a little bit more complicated. So it's not just simple live data. What happens when that happens? So what we do is, the first thing we're going to have to do is briefly pause the controller, but it's very brief. It's actually not even noticeable. It's like sub-millisecond pause. When we pause that, we would actually take a snapshot of the existing replica. So that way, we make sure that the live data at this point is blank. And then all this real data is now captured in 2 snapshots. This is not a snapshot taken by the user. This is a snapshot taken by the system. Then what we do is we add a new replica, but we added in, this is a standard, storage trick. I think all the storage guys know about this. We just add a new replica, but it's in write-only mode. This new replica obviously has no snapshots. It's literally a blank disk. So now at this point, 2 replicas both are basically blank. 2 pieces of it, both are actually blank. But the difference is the existing replica has all the historical data also in it. That's why it can be read. But the new replica really can only be written to. So you unpause and then the operation basically continues. So at this point, all the writes will go to 2 replicas, but the reads would come from the good replica. At the same time, we sync the snapshots. We just sync the snapshots over. That could take, few minutes, a few hours, could take a while. So this is the time we'll actually rebuild. During rebuild is actually when the volume is quite vulnerable, because if you lose another replica, then you lost data, right? I mean that's the reason why sometimes people have 3 replicas, but that will certainly increase the likelihood of rebuild success. But the rebuild, like I said, could take a while. And after rebuild is done, you set the new replica to read-write, and then both sides are basically synchronized again, because all the writes are, we've been keeping the live data up to date. And at this point, when the sync finishes, sync is almost like a custom rsync that we've written, very simple, just sync sparse files over. So that's it. That's how a rebuild is done. Again, not super complicated, because we're worried about 1 controller at a time, and it's there's really no pause. There's a brief pause, but during the pause we've only taken 1 controller, or we've only taken 1 snapshot and set some mode. So this is sub-millisecond kind of pause. So the user doesn't really see it. Oh, this is really the one.
Hey, Shannon, before you move on from replication, there was a question. Can the replication level change at runtime after the volume is created? Like if I wanted to go from 2 to 3 replicas, or does it have to be set at the beginning?
Currently, we cannot change it, but it's definitely doable.
Yeah, I think the the architecture, from architecture point of view, it's flexible, but I think right now the APIs, you just set it at the beginning.
Awesome. There's another question that just was: is the source for the custom rsync in the Longhorn repos? If someone wants to look it over, Michael was asking.
Oh yeah.
Yes, the source. In fact, we start that as a separate code base. You can find that at let me see. I think it's called the Rancher Sparse Tools.
Yeah, it's there. We'll post it later. It's sparse tools. It's called Rancher/sparse-tools. But it should be referred to from somewhere from the Longhorn engine anyway, right? Maybe it's somewhere in the build scripts and stuff.
So it's in the window file. Yeah, because we use that as a library in the Longhorn engine.
It's pretty straightforward. And we never had any problem with it. This is a really cool part of Longhorn that I'm really excited about, because as you know, the way Longhorn works is replicas sit on disks and controllers control replicas, and then we have a front end. We actually have a couple of different kinds of front ends, but just doesn't matter. I'm not going to get into details. But the front end takes the controller, which is a user level program, turns it into a kernel device. So that's the architecture of Longhorn. And then I think early days of Longhorn, we were thinking maybe, because there's actually a protocol between controller and replica, obviously some kind of a network storage protocol. And we were thinking, we probably need to version the protocol in case controller replica gets out of sync and stuff like that. Then actually pretty soon we realized that's not really necessary, because it turned out that we could live upgrade the whole controller replica as a whole without really impacting the user, without impacting how this volume was consumed, because we also have a front end. I mean, this is a perfect example of another level of indirection, which is absolutely necessary, because I got to map this thing from user mode to kernel driver to a kernel device, right? And that kind of solves the upgrade problem for me. Obviously, upgrading the front end will almost require upgrading the kernel, so that will require a reboot. But in Rancher, upgrade controller and replica does not really require even disrupting a single volume. So the way we do it is we can basically create, say this is the new version of controller and replicas. We just got that created, pointed them to the same disk files. Someone asked earlier, can we resize disk files? I mean, we can resize disk files with this way too. And then after they're up, then what we do is we can just almost pause the front end and atomically flush the writes, and then atomically basically flip over this thing, and then just eventually garbage collect or delete the old controllers. So this is really cool because I mean I've always had problem upgrading storage software. If you're not careful, it causes all kinds of outages. So essentially with Longhorn, you can imagine that we keep saying we have 100,000 volumes. I mean, I could just go in and say, I'm just going to upgrade one volume. Maybe, it's not really a user. I just upgraded one volume and see how that behaves. That's successful. Now I upgrade 10 volumes. Now I upgrade 10% of the volumes. And if any time it doesn't work, we can roll back, right? So this is the kind of things I think people with Rancher, with Kubernetes, with swarms, with microservices sometimes take for granted, but in the storage space, this is still relatively uncommon. And I think I hope Rancher, I hope like Longhorn could make these kind of practices more popular. It is really quite powerful if you essentially can live upgrade and partial upgrade and sandbox and roll back new versions of the software. So this is what we're going to be able to do. So the last thing I want to talk about is Longhorn, in terms of deployment model, is actually very sophisticated. Someone asked about that too, because we have a lot of flexibility on how we place replicas and controllers. So basically, if you place replicas on the same host as controllers, it becomes the hyper-converged model. You basically have the same set of hosts serving the underlying backing storage, as well as the same set of hosts essentially consuming it through their own controllers. But we could also separate replicas from controllers. So someone was asking, if I have a Kubernetes cluster, can I have a separate Longhorn storage cluster? That's exactly how you would do it. You basically run the controllers now on your existing Kubernetes cluster, but your replicas will run elsewhere. So in that case, you better have a high-speed storage network interconnect between those two set of servers. That's a given. But if you have that, then you basically have a dedicated storage server architecture, and all that's changed is just scheduling, right? Scheduling of replicas and controllers. So you can have that. So I want to just describe what actually is real now and what's still being worked on and what we're going to work on in the future. As I demoed before, I actually demoed on the single node. It works with swarm clusters, for detection, replica rebuild, all that stuff works. A snapshot backup, recurring snapshot backups, all these things work. UI and API, as I kind of demoed, this stuff works. But there's actually a huge set of work still remaining. And they're not individually not that big, but there's work. We're working on a Kubernetes flex volume driver now. We actually had it before, but it needs work, and have a way to just deploy Longhorn on any Kubernetes cluster. And then the second thing is we want to just be able to deploy Longhorn cluster from Rancher catalog. That's the main Rancher integration. So Rancher basically kind of takes care of the deployment aspect, because today, like, you still need to manually set up these Longhorn managers on every host. Once it's deployed from the catalog, everything will be automated. I explained like controller and replica can do live upgrade. Conceptually we can do it, we really still haven't coded up. So we want to code it up. When Longhorn orchestration happens, there's actually this event log is already in, right?
We're still reviewing, doing the PR, and
Yeah.
that is close to be emerging.
Yeah, so when when these orchestration activity happens, like I'm detecting faults, I'm repairing faults, we really want to give user more indication of what's going on. So today the backup really only works for NFS, and we want to also make it work for any kind of S3 compatible storage. The big thing we need to do there is figure out authentication, authorization stuff, because S3 is authenticated. NFS usually is not. So it's simpler. Today, like the replica scheduling is fairly straightforward. I don't think we're even doing any real scheduling. All we're doing is we're trying to use anti-affinity to put replicas on different hosts. So when I did the demo with one host, obviously they run on the same host, but when they have multiple hosts, they run it on different hosts. But really for this to be production grade, we probably need to take disk capacity and IOPS, things like that into account. We can over provision these, but they should be scheduling criteria. So someone asked before, does Longhorn work with existing file directories or multiple disks? Today it actually only works for existing file directories. Replica is actually just created as right now I think these sparse files are just created on a Docker volume, but in the future for it to be a real storage system, at the very minimum it should manage multiple disks on the same host. There's a lot of stats we can actually easily collect and display. I think that will make the system more usable. And right now, like everything about the UI and API is unauthenticated. It's okay, if you kind of just want to use it to develop drivers and not really expose it. I mean, you really shouldn't expose it to the world, but at some point maybe some people want to do that, so we got to put in authentication and user management. Volume encryption I talked about, and then last but also very important, performance tuning. We've actually done a lot of stress testing, because for me I almost feel like stress test reliability is probably the most important thing, and that also helped us with finding some obvious performance problems, but we haven't done any performance tuning at all, other than the OpenEBS folks, published some very early results, which actually looked pretty good. But other than, because we use very simple technologies, everything is written in Golang, so it's pretty easy to understand. But I'm sure there's room for performance improvement. So that's it. That's my very quick run through of the details of Longhorn. And Shannon, any questions?
Very, very quick, Sheng. That was really an hour and 40 minutes in. I love it. Yeah, and we still have almost everyone here, so thank you everyone for being so engaged. The questions are endless. I probably have 20 questions, Sheng. So we'll dive in and start asking. Feel free. I know people have to leave, so if you need to leave, we'll try to get to your question as soon as we can, and we'll answer them all. You can always come back and watch the recording. Let me just dive in and start asking questions. So some of these you probably already answered. So if you already answered it, I think you can just kind of comment on it quickly, and we'll keep moving. But one of the questions that Christopher Jackson asked was, he said, it had to do with scheduling, and he said, can Longhorn be set up in a way that allows you to schedule based on other policies like racks and rows, and sort of to try and split up the resources as much as possible between hosts?
Yeah, I think by design it can. Right now I said, if you look at the Longhorn scheduler, it's really simple. It doesn't even schedule capacity. So I don't see any reason why we shouldn't extend the scheduler. It's a very modular design, and it can be extended. So a bit of a backstory about scheduling is we kind of wavered between. At some point, we were thinking just use the Kubernetes scheduler and Swarm scheduler to actually schedule volumes, and it turned out that these schedulers by default at least, are not really built to schedule storage, right? And I mean, they have certain things like simple anti-affinity, but doesn't really understand things like disk capacity and IOPS. And usually these schedulers all have a way to kind of do a custom scheduler. So we started extending it. Then pretty soon we realized maybe we're not going to bother. Let's just have Longhorn Manager, do its own scheduling, and then basically today I think that's how we're going to do it. We just kind of end up telling like even Rancher or Kubernetes or Cattle or Swarm, just say start the replica here, So we kind of take the decision loop out of these orchestrators. So now orchestrator is effectively only scheduling compute.
There's a question Ronnie asked. He said, if the volume is locally available, contiguous with the controller, will it read that local one only, or will it always read from both, or will it read from either?
No, I think today, it just, is it random? It reads?
It's basically random. I think it's probably round robin.
Yeah, I think the way it's supposed to work is either random or round robin, some kind of a policy, and then if something fails, then it's supposed to retry on the other, right? But I don't think we have right now. I don't think we have anything. Like imagine if you have a replica that's actually on the local host. Ideally, you probably want to optimize read just out of that. But I don't think we even have that sophistication.
Great. Todd asked, he said, instead of mirrors and possibly RAID, have you considered using erasure coding across containers?
Possibly, yeah. I mean, there's really nothing would prevent it from. It is rather complex, and but I think that could be a future enhancement. I personally don't understand erasure coding very well, so, but I think I'd love to work with the community on this. Like if you look at the current controller logic, I hope it's simple enough that other folks will be able to plug in this kind of stuff.
One question Kieran asked, he said, what in your view are the advantages of Longhorn over other containerized storage tools like Portworx?
I mean, it's just, I don't know if they're advantages or disadvantages. Like one thing, it's just different. One thing is, I have very little visibility into how Portworx is actually designed. I mean, they could internally, it's unlikely, but it could just be like Longhorn. So, but one thing I would say we paid some attention to at Longhorn is just going back to my initial motivation. I just was very scared of this kind of sophisticated storage systems that has to be designed to handle so much aggregate I/O operations that comes in at such a high, and a single software bug could cause potentially failures of the whole cluster. I think Longhorn is really more of a. I think that's probably the key motivation behind Longhorn.
Jeremy Ulebrock says, are we going to announce, or will the source code be added to the GitHub? What language is it in?
Oh, the source code is all in the GitHub. Everything is in the GitHub. It's just not in the Longhorn repository. There's Longhorn repository is just a few readmes, I think. Then there's Longhorn Engine, Longhorn Manager, Longhorn UI, sparse tools. There's just a whole bunch of other repos. So if you actually run the scripts, you'll see what it's actually doing. Yeah, it's all in Go. It's all in Golang. It's actually reasonably simple. I know I said we worked on this for a long time, but I think what happened was kind of a learning experience. A lot of the code we wrote initially for maybe the first year and a half is actually, I don't think they're in the repo anymore. So we used to write a big chunk of code in C++. That's all gone away. And then we tried different ways of writing front end. That also kind of gone away. A lot of that also gone away. And we also tried different ways of orchestrating these controllers and replicas. A lot of that is also gone away. So.
Another question Michael Waltz asks, he says, does Longhorn depend on communication with the Rancher master server and continue to work as long as controllers and talk to each other. So I think questions there. Does this rely on any Rancher functionality? I think you've already said no.
I mean, it doesn't. You know, it really doesn't. It's like this is sort of the data plane. The control plane, you could argue maybe it does. Like the control plane, like if you think about it, this cattle cluster is like Rancher, right? So if you kind of, you know, I mean, it doesn't rely on it, but almost like Rancher is a customer of Longhorn at this point.
So there's a question from Keith Raja. He said, is it possible to use multiple disks on multiple hosts? I think you already talked about this when you were answering questions. But
yeah, it is possible. We haven't implemented it yet.
And then another one is a host on Longhorn a Docker container or a real machine? A host is a real machine.
It's a I mean, when I say
VM.
Host, it's a node. It's a VM or physical machine. It's a machine it's a machine that's able to run containers.
Right.
I mean, I can kind of. I mean, I was showing in my demo that is I got a single host setup here, and you can kind of see what's running on that host. You know, you see all the controllers and replicas and UI and Longhorn driver, Longhorn manager. That is a host.
There's a question. David asked, is Longhorn going to be open source? Just to be clear, Longhorn is 100% open source. It already is. You can already pull it down, use it as you like, fork it, do anything you like with Longhorn. It's a 100% open source project. There was another question from Arash, and Arash said, is it possible to use Longhorn with cloud platforms like CloudStack, or would it be possible in the future?
Yeah, it could be. I mean, it's certainly, you know, it totally can. Longhorn actually has a front end. Like right now, if you create a Longhorn volume, the way I showed it is mounted as a Linux device, right? But we could actually also expose it as an iSCSI target. So in theory, that could also even work with VMware, you know, with vSphere. So it's certainly possible.
Frederick said, what's the overhead on read writes that we can expect to sacrifice due to the sparse file usage instead of simple blocks?
Oh, that's a very good question. I've actually done a fair amount. To be honest, let me tell you, in my own measurements, I couldn't really tell. But I'm not methodically doing storage measurements the right way. But I did a lot of research online, just searching Linux sparse files and stuff like that. It's a complex topic because obviously different file systems like ext3, ext4, XFS, they're all different, right? Everything implements sparse file differently. But I think what I gain out of that is like nobody seemed to care. I don't think there's any real overhead because the nice thing with sparse files is Linux maintains the metadata. So you know, file system is doing a lot of metadata management already. So I find it a lot better to use sparse files than say if we manage say a bitmapped metadata ourselves. Then every write would actually have to turn into multiple writes. You know.
I think you've already answered this. Daniel asked, can multiple containers connect to the same volume? The answer is no, correct? It's one volume per container.
No, it's actually not.
At the same time.
So it's not as simple as that. Multiple containers can connect to the same volume if they are on the same host. That's just how Docker works. You know, if you're on the same host to begin with, of course, because it's volume from, you can of course connect to the same volume. If they're on different hosts, the way the way EBS works or the way Longhorn works today doesn't. But actually, someone even filed a ticket just I think yesterday. Strictly speaking, from a technology point of view, you know, there's nothing really stopping a volume to mount read-only on multiple hosts, as long as only one host can write to it. GCE actually support that. So, you know, I mean, Longhorn can support that too, but I mean, right now that's not even in the plan.
Awesome. There was a question from Adam. He said, will Longhorn be able to automatically attach a volume to a container when a container is deployed to a randomly scheduled host?
Yeah, that's actually not Longhorn's. The way that works, if I do a sequence diagram, the way that really works is when a container gets scheduled on that random host, the container is actually going to call the volume driver or Kubernetes volume plugin, flex volume plugin, and then the plugin essentially calls Longhorn to either attach volume if it's an existing volume or create volume if it's a new volume. So that's kind of how it works.
Awesome. Can it be used with the cattle orchestrator instead of Kubernetes? Adam asks. Adam, both of those are coming. Yeah, I think it'll be used. You can use it with cattle, Kubernetes, Swarm. But then someone else asks, will you be able to use it without any of these? And the answer is yes. I mean,
that's what we
Longhorn is meant to. You'll be able to stand. It'll stand on its own. It'll always be a project that will exist, and then any integrations to orchestrators, like Cattle or Kubernetes or Swarm, will be implemented by us or the community or anyone. Anyone could take Rancher and integrate Longhorn integrate it with anything that they see value in. Everything we build here at Rancher is open source, so it's really geared for people to use and take and push in the direction they want. Gurmeet asked a question, Shen. He said, when a replica is rebuilt, is it rebuilt completely from scratch, or is it rebuilt incrementally based only on the data that it missed?
Oh, that's a great question. So I actually explained it in my blog. Like imagine if you had two replicas, and somehow the network connectivity to the second replica broke for like 10 minutes, so you missed some data. But it's too long, so like somehow you miss too much data. It's impossible to catch up or retry. So you say that replica is bad. So the way Longhorn works today is we just throw it away and then rebuild from scratch. But let's just say if it's a 1 terabyte volume and it's not sparse. Let's just say if it's actually been written to, it's probably going to take days to catch up. But obviously, we should be able to do it better. If the old data is still around, we should probably try to use the old data. So that's probably an optimization we can make. But today it was just simpler, just start from scratch.
Awesome. Here's a question that Christopher asked. He said, could or should Longhorn be set up with two networks, a public front-side network and a cluster backside network similar to Ceph?
Yeah, I think so. I mean, we haven't really done enough real performance, and I really think, I mean, the problem right now is the real challenge is the network for between controllers and replicas. It's that this stuff really consumes a lot of bandwidth. So this could, I think let's just say what's on the bottom is like a management network or something. But if it is a dedicated storage network for that, I think that might be a good idea. But like I said, we haven't. One thing is Longhorn is very resilient because it's simple. So we don't tend to run into like I've tested all kinds of stuff. I even tested like I would like completely pause a host or something, pause the container running the host, and then I unpause it's able to recover. So today basically, if the network is saturated, all you see is just bad performance. So you don't tend to see as much cascading failures with Longhorn. So I would say it's not absolutely necessary, but if you're in an environment you just want guaranteed storage response, you should probably have that.
Here's a question that Mardo said. He said, does Longhorn work only for Docker containers, or could you support like LXCs?
I don't know. I haven't looked at LXCs. I don't see why not, because it will probably take some effort to write new drivers and stuff, but Longhorn exposes a Linux kernel device, right, or iSCSI target. So certainly VMs can, QEMU, VM, even vSphere can even use it. So.
Scott asked a question about Swarm. He said, if you're using Swarm and a container dies on a host and is restarted on a new host, does the volume automatically move to the new host also?
Yeah, so the volume actually exists. That's exactly right. The volume actually exists in the cluster. It doesn't, but it's attached to a host. So yeah, so the way So the way the plugin will work is we'll just attach the volume to the new host.
We got maybe
And the process of attaching actually forcefully detaches the volume from the old host. So just in case the old volume, you might think the host has gone down, but the host might still, like it actually might be running. In worst case, it might even have a connection with the replica, right? So what Rancher orchestration does is we actually make sure, Longhorn orchestrator does, we actually make sure the replicas are forcefully detached from whatever other controller that might be controlling it.
Gurmeet asked another question, and just to give you an idea, we've got about 6 or 7 more questions, so feel free to keep asking questions. I know we're coming up on 2 hours. Gurmeet said, when the replica is written to a file system, does Longhorn make sure that the file system persists the data on disk immediately, or is it left for the file system to decide when to do it?
I mean, obviously, yes. So we use, I think it's used direct I/O, but to the extent the file system respects that kind of stuff. Sometimes there could be misconfigurations somewhere in the stack. You probably want to make sure. But I'm pretty sure. What I worry about is sometimes you have like complicated setups like these host VMs that's run on some NFS on the network, right? But I'm pretty sure if your bare metal machines actually running local disks, I'm sure Linux is very good at that.
David Vasquez he had asked an earlier question about running Rancher in a couple places, and he was wondering, would this be something that could replace, say, NetApp if they're using a NetApp for back-end storage against, say, a Kubernetes cluster or something? So that type of NFS filer, NetApp type of thing, is that something you can replace with this, or given its block storage, is it not a great replacement?
I don't think so. I mean, maybe in some very limited, obviously depending on what you do. What you do is exactly what Longhorn supports, but like if you think what a NetApp can do, with NFS you can actually mount the same volume from everywhere. Like NFS is really far more powerful than the distributed block storage. And the other thing is, even with Longhorn, we would back up to NFS, or S3. So Isilon, NetApp, I mean that kind of stuff actually is you see here actually use a NFS endpoint for backup. So I think there are a lot of ways Longhorn can actually work with NFS. I don't see. I mean, with filers or enterprise storage, I don't see that. I mean, I think Longhorn might be useful if you just want to use local disks.
Okay. Are there any logs maintained on replicas for two-phase commit in case one replica write fails? Also, is there any destaging phase to move data from the log when the write is confirmed to the client? That was Mark's question.
Yeah, it's so it's actually we're simpler than that, So really, all that's kind of going on is every write comes into so the write, a write goes to the Linux kernel device, and then the Linux kernel device through the front end effectively calls the controller to perform the write, and the Linux kernel actually does all kinds of retries and all that kind of stuff already, does batching. So when it comes to the controller, it basically really just want to make sure that we make a best effort at that time to write it to all the replicas. And the way Longhorn does it, we don't really like record it in a journal and try to write it later. It's very straightforward. We just go ahead and turn around and try to do all the writes. And obviously, if any of the writes fail, that's okay. If all the writes fail, then we have a problem, right? We just propagate the error back.
Awesome. There's 3 more questions. Ronnie said, in terms of resources, how demanding is one controller?
It's not demanding during normal use, but I've done like kind of a simple benchmarks. If you do a DD or something, you could see you're pumping, like if you're pumping 100 megabytes per second into a volume, I mean, then it takes 100 megabytes per second worth of CPU to keep the controller running, right? So the controller is basically just shuffling bytes, you know. I mean, I don't know. Honestly, I don't even know if it could be optimized. But you know, but that's what it does. It's not bad during normal use, but I've you know during but it just moves bytes.
Can Keith Raja asks, can I mount the volume to the bare metal host?
Yeah. The volume is the volume actually shows up in the host. That's how it works. The volume, you know, you see here, I'm actually on the host. That's exactly how it works. I'm actually on the host running Longhorn, and this is exactly on the same host. Those volumes exist. And Docker volume driver, Docker volume plugin basically takes the volume and mount it to the same host. That's exactly what Docker volume plugin is doing. And I think I tried to mount it manually earlier too.
Awesome. Last question. Scott said, is there any auto recovery of, just when I say last question, more come in. Is there any auto recovery of replicas if the host is powered off or a disk dies, similar to Ceph?
Yes. That's a given. So the way it works is the controller actually, by virtue of being the data path, it detects replica failures very well. You know, we don't really need another way to detect replica failure. Basically, if the controller can't read or write from a replica, we know something's wrong, right? And especially for write, I mean, that's very bad. If it's read, maybe you miss a few reads, maybe you come back, you know, it's still okay. So once the controller detects a replica as bad for whatever reason, the orchestrator will start to rebuild the replica elsewhere.
All right. So and then Keith Roger, just kind of follow-up question was, how about to mount the volume to another bare metal, or if you had two bare metal modes?
Yeah, if you like I said, each Longhorn volume can really only be attached to one host this is just a property of distributed block storage. So you know, these are all attached now. But let's just say I can detach it. Oops. I can detach it from this host, and then if I had multiple hosts, I can attach the volume to another host.
Awesome. So have you done any, Matthew said, have you tried using a database with Longhorn? How did you find the performance, loosely speaking?
Oh, I haven't. I mean, I really haven't. But I've done enough, I've done enough of my tests to feel pretty comfortable myself, but storage benchmarking is a very controversial and very difficult area. So, you got to really have the right setup, right workload, right hardware. But I must say, you just got to look at what we're really doing. We're really not doing very much. And I've run FIO, I've run these kind of things left and right. I mean, it's really quite good.
Kieran just said, what happens if all the replicas down at the same time? I assume you'll have the backup to recover from. That's really all that you have.
If it's all the replicas are down at the same time, the volume is in unhealthy state. It's just bad. I mean, the volume is basically in error state at that point. You basically host.
But you can revert from backup, right? Whatever backup.
Yeah, you better have a backup.
All right. I think I think that's all the core questions. Oh, there was one last one. Are read writes synchronous or asynchronous? I think you said they're all synchronous. At least writes are. Or reads are synchronous as well?
Yeah, I mean, reads have to be synchronous.
Yeah. Okay. So I think that's everything, Sheng. Thanks so much. There was loads and loads of great questions. Everyone had lots of things. Just please get involved. Try Longhorn, pull it down, play with it. Send us more questions. You can always email Sheng directly. He's just shen@rancher.com, or you can email me, or info@rancher, or you can post issues. You can join us on Slack. I mean, we try to make it really easy to find us out there in the world. I did have a couple of slides just on just some quick updates. on kind of the next release and what's coming on. I'll just take a second on those. For myself, just pull this up, and you guys can see my screen. Basically, we released 1.56 recently. So if you haven't already, 1.5 released in March. 1.6 is going to be releasing in early May. So 1.6 has a handful of things that we're improving on the catalog and HA proxy. We're going to be certifying Rancher ABS. There's two things that are kind of borderline to make it into 1.6. One is the scheduling enhancements, which basically is a bunch of work we're doing to do even scheduling across pools of hosts. And then Kubernetes 1.6 support is sort of borderline for 1.6. We've been doing a lot of testing. So far, it's we've seen enough issues that it may end up being 1.7 instead of 1.6. So, but we'll know that in the next week or so, and we should see 1.6 head out, probably by the end of next week. With that, I will say thank you to Shen and everyone. If you haven't already, get involved with Rancher on GitHub. Our projects are very easy to find under github.com/Rancher. Or if you want to try Rancher, just hit try.rancher.com and you can get your own Rancher environment that we host, and give you an easy place to play with and try all the stuff we're talking about. The training classes are run once a month. If you haven't attended one before and you just want to get the lay of the land, we spend an hour or two just diving into what is Rancher in depth. So rancher.com/training. And obviously, if you have questions about Longhorn, go to slack.rancher.io and you can join the Rancher Slack project, and we're all on there. You can ask lots of questions there. With that, I'd say thanks to everyone. Shen, thanks. Sheng Liang, thanks. And everyone who attended today. I really appreciate all of your time and your patience while we dealt with the audio issues. We will be back next month. I think we're going to be talking about GitLab and CI and a lot of other cool stuff. So we'll be posting next month's topics. If you have ideas for topics, just send them to Shannon@rancher.com, and if you're interested in speaking, we would absolutely love to have you. And with that, I'll say thanks and have a wonderful afternoon.